this is ordinary tail is chlorine. We are putting chlorine in the presence of anhydrous aluminum chloride. So when it removes here, here see there's a double bond here. Okay. So this is giving its electrons to this chlorine. That's why this chlorine is being attached. So if this is removed, this carbon, one electron it lost. That's why it is getting a plus here. Okay. Plus Cl, AlCl3 minus. So normally we don't show hydrogen, but for resonance we are supposed to show this. So hydrogen it will give its electron to reduce this plus, and this chlorine will give its electrons to hydrogen. So then what is the product we will get is benzene ring, chlorine here, plus HCl, plus aluminium chloride. Okay. Then intermediate. So how to do the intermediate? So the same structure here. Okay. Chlorine here, plus here. So in order to neutralize this plus, this electron will move. So that is one resonance structure. So here. So here it removed, therefore plus comes here. So another one, benzene ring here, chlorine here. So it will come here. So there will be a plus sign. So else, if you like, you can further write like this. Sometimes examiner will be happy. The intermediate carbocation, involves in resonance to get stabilized. Okay, depend on the marks and everything. So if they ask more about the intermediate, you can describe like that. Why it is involving in resonance. One reason to get stabilized. So first of all, what you write is, if they ask, write down the mechanism of chlorination. This one, chlorine AlCl3, that one. Then this step. So after this step, this is the final one. In between that, you can finally talk about the intermediate also. Why it is getting stabilized here due to the resonance property. Okay. Okay. After writing that.
Miss done.
Okay. So next one could be heading bromination. Fourth one, bromination. Okay. What is bromination is for a benzene ring. If you put Br2 in the presence of FeBr3, we will get a benzene ring like this, bromine. Okay. So similar, bromination and chlorination similar. Chlorine, if you put Cl2 in the presence of anhydrous aluminium chloride, what happens? It is an electrophilic substitution reaction. Chlorine gets substituted. Okay. So if you want, you can write under chlorination, you write down this under chlorination mechanism, electrophilic substitution. And electrophile is Cl plus. Write down this under that. I can give that. Under chlorination, what we wrote earlier, mechanism. Put the mechanism and write what is the mechanism is electrophilic substitution. So what is the electrophile is Cl plus. Similarly, for bromination, the mechanism is electrophilic substitution. Okay, electrophilic substitution. Similarly, the electrophile here is Br plus. See, why I am talking is that this benzene ring is here. So in the place here, Br is coming and being substituted. The hydrogen is being removed and Br is coming. That's why we call electrophilic substitution. So sometimes we ask the electrophile. In the chlorination mechanism, electrophile is Cl plus, mechanism is electrophilic substitution. In bromination, also mechanism is electrophilic substitution, electrophile is Br plus. Okay. So every reaction is better to know that. What is the mechanism? That means already you studied reactions also electrophilic addition or electrophilic substitution or electrophilic addition. What is the reaction type and what is the electrophile or nucleophile in that reaction? Okay.
Miss, electrophile is proton acceptor, electron acceptor.
Electrophile means yes, it is searching for electrons. Plus Br plus, Cl plus, E plus. Okay.
Okay.
That's why it is going with the benzene. Okay. Benzene is rich in electrons. It has 5 bonds. 5 bond is moving and everything. Delocalization properties also there. Okay. So the bromination mechanism is okay. Bromine Br in the presence of FeBr3. Okay. So it will make a bond like this. So we will get Br plus and FeBr4 minus. So electrophile is Cl plus, electrophile is Br plus means that should form. That's why first thing electrophile is formed Br plus and FeBr4 minus. Then we are treating that with benzene. Then what happens is now benzene ring is here. So Br plus it needs electron. So this is benzene ring, it is giving electron. And FeBr4 minus is okay. Then what will it form is benzene ring here. Okay. So Br will go and attach here. Hydrogen I am showing here. Normally every position has hydrogen. In order to write the mechanism, actually hydrogen in this place. So there will be a plus sign here. Why? Because there is a bond between this carbon and this carbon. This only gave its electron to Br and Br came a bond here. But one electron is reduced here. Therefore, that plus sign you should show. The thing happening is carbon-carbon double bond. Normal benzene ring we draw. Can you remember that one? The same thing is here. What I am telling is, you should understand that why that plus is there. So this is the 6 carbon we draw, double bond, double bond, double bond. So here, if I break this bond, okay, this bond was common to this carbon and this carbon. Now, if I break this bond and another bond is forming here, Br is coming and attaching, but that bond is not here. That's why we are putting the plus sign here. That is the reason for the plus. You get the reason for the plus now? Hello?
Yes, miss.
Yes, that's really important. Why plus is coming? Because if you identify the plus correct position only, you can quickly draw the rest of the intermediate structures. Okay. So here we have FeBr4 minus. Okay. So that we call as intermediate carbocation. Then what happens means this hydrogen will give its electron to this, and what finally we get is Br here. Okay. Br here plus HBr. This hydrogen and one Br gets combined plus FeBr3. Okay. We can draw the intermediate structures for this. Okay. So how we draw is now this is benzene ring. Okay. Br hydrogen here. So this is plus. This is one structure. But you know, benzene, 5 bonds they can move. They won't stay in a fixed position. So next one, what will if we look at, there's a plus sign. So it is not stable. It will try to give its electron to this. So when it try to give its electron, there will be another resonance structure. So what is it? The bond will move to this position. Therefore, no plus here. But due to the bond move, you see in this position, here this carbon, only 3 bonds are there. Therefore, plus arises here. Okay, then we can draw another resonance structures. Again, in order to neutralize this plus, this will move. Therefore, here, Br here, hydrogen here, and a plus here. So this also you should understand. This what I am drawing is the 6 carbons now. Benzene, there are 6 carbons like this. So in between there is double bond. That's what we studied from a benzene structure. So that benzene structure, another way only we are depicting. Now what happens is, what I am telling is, so if a double bond is broken in this position and we are putting plus here, this double bond is moving to this position. So if this double bond moves to this position in the next structure, a plus will arise here. That only I am drawing that in that shape. Are you okay with it? Hello?
Yes, miss.
Okay. If you have any doubts, ask. Because for exam, each and every point should be clear. By plus sign, where double bond is moving. You write down this when you are writing if you have any doubts. That means you should know where this plus sign. And only if they give any compound like that, when you are writing the mechanism, it won't get wrong. Where the plus sign is coming and where minus sign and everything. You must know the reason why this plus is coming, why that plus is moved. When it's moving, you must know where to put the plus correctly. Okay, so that is the reason. If you feel difficult, you can draw the benzene compound C6H6 and compare with that initial. So that structure easily it goes in mind. So after that, when you complete this, it will be okay, right and there.
Miss, can we do a 1 hour class today?
Okay. The next 1 hour another day.
Miss, are you free tomorrow?
Tomorrow I'm free. This same time, okay.
Okay, miss. Aren't you free in the morning?
Morning also 7:30 to 8:30. Are you okay?
Sure, miss.
Thing is, I have another class at 9 or 9:15. I should start. That's why 8:30 sometimes. If I postpone also, that girl has another class at 11:30. That's why.
So can we do
7:30.
at 7:30?
Yes, 7:30. Okay.
Okay, miss, sure.
You inform the management or in the group post. Okay.
So I'll leave a message in the group.
Okay. That's why they said anything changes, you should inform the out.
Okay.
You can get it right, what I'm telling. Hello?
Yes, miss.
Okay. Which school are you?
I'm doing private, miss.
Okay.
Miss, how can we explain the benzene by sigma and pi bonds?
Sigma and pi bonds means you want to explain the resonance, delocalization, those properties.
I'm doing chem, which in that they have asked how to describe the benzene.
Okay. So when you are describing the benzene, you can write, you can describe about its bonds also. So one property you can write, all the carbon-carbon bond lengths, you can talk about the bond lengths. And another property is pi bond moving position, the delocalization property you can talk. Shall I give the note? How to describe the benzene? Hello?
They have asked sp2 hybridization.
Yeah. You want to describe this hybrid sp2 hybridization is what is now here there's carbon, right? So it has 1, 2, 3 bonds. So the every carbon it is sp2 hybridized. You know, right? sp2 sp3 hybridizations. How to find?
No, miss, can you explain that me tomorrow?
Oh, okay. You want to discuss hybridization property and the detailed structure of benzene, right?
Yeah, how to
Mechanism.
describe it.
There's one more mechanism, I think, nitration.
Let's do that also. And
Okay.
oxidation.
Okay. Oxidation, nitration, and activating, deactivating groups. Are you okay with it?
We don't have that.
You are doing ASO, A2O, which one?
A2, miss.
A2. Okay. So tell me what are the section I'm supposed to do tomorrow? This one, hybridization thing, nitration.
Describe benzene and hydration.
Okay.
Forming, yeah, that's it, I guess. And then we can do questions.
Okay. Okay. Questions. Papers, right? Okay.
Yes, miss.
Okay, then I'll end today's class. Tomorrow, 7:30 a.m. Let's continue.
Okay, miss, sure.
Okay. Okay, bye.
Bye.